video. Today we'll be solving up a new question on Leetcode, which is find in mountain array. This is the daily question, and the number is 1095. Okay, so first of all we'll go and check what is the problem. We'll see and understand the problem, and then we'll move ahead to solve the question. So the question says that you may recall that an array in a mountain array if and only if like the length of the array should be greater than or equal to 3. So this is the mountain array if and only if the length is greater than or equal to 3, and there exists some I where 0 is less than I less than array dot length minus 1, such that the array of 0 is less than array of 1 is less than array of I minus 1 and array of I. And then these two conditions are literally what I mean is just like a mountain. So first of all I'll draw the conditions and then you'll see. Okay, so the conditions, to be honest, this says that this is just like a mountain. Okay, so we'll change the color of the pencil first of all. So here we go. So this is just like a mountain, and in this mountain what is happening is these points are increasing. Okay, there will be a peak on the mountain, and then things are decreasing. In this manner the questions move forward. Okay, so we'll first see the question itself, what are the conditions that are being given, and this is all the question is. If you guys can read it. So given the mountain array, return the minimum index such that the mountain array dot index equal to target. So what you guys are given is just like an array. Okay, so you guys are given an array. Okay, right, the array could be anything like 1 2 3 then 2 1 like this, and the target will be given. The target will be equal to, let's just say, 3. Okay, so we have to find it out and we have to return the index. So for example, in this case the index will be 0 1 and 2, so index will be 2, right? So we have to see out this thing. I hope the question is little clear. Okay, but the thing is, the submission makes sure that there should be 100 calls on mountain array dot get. This is just acting as an interface, right? Now if I just wanted to conclude what is the interface here given is, so mountain array dot get will help you to get that value from that array. Okay, and dot length will return you the length of the array, right? So that's the question. Okay, so we'll first move to the first test case, and then we'll see how do we proceed to this question. Okay, so in this the test case is being given such that arrays is equals to 1 2 3 4 5 and then 3 and then 1, and then target is given as, what is the target? It is 3, right? So let me move to the iPad and then I'll explain you what is happening. So here we have 3. Okay, so 3, there are two indexes, right? 3 and here we have 3. So first is the 2 and the other one is 0 1 2 3 4 and 5. The other one is 5. So which is the minimum of 2 and 5? It is 2, so answer will be 2. Okay, so we need to understand that how we need to do this question. If I talk about the brute force approach, then first of all you will just travel into an array. Okay, so just apply a for loop, and inside that for loop I equal to 0, I less than array dot length. Okay, and I plus plus. Inside that, if a dot get I is equal to target, then literally what you'll do, you'll return that I. Okay, you'll return that I. So this is the whole approach, but this is not the optimized approach. What we need to think is more optimized approach. So in searching, if we wanted to do something like the array is sorted, as you guys can see that 1 2 3 again 4 and 5, see this is sorted and this part is sorted. So what do I mean by it is, just see this thing like this: 1 then 2 then 3 then 4 then 5 then 3 then 1, right? So this is forming a mountain kind of a thing. Okay, so from here to here everything is sorted. From here, this point till this point, everything is sorted, right? So what could be the approach? The approach can be, first of all, find the peak element. Okay, once you find the peak element, try to search in the left half. Okay, so from this position, right, from this position to this position, you will search in this array. Okay, in this array you will search. If we'll get the answer, we'll return it. Okay, so we'll return the I. Otherwise we'll search from right. Okay, so from peak to n minus 1 we'll search in binary format, like binary search format, and we'll return I. If in both of these cases, in from upward to downward, we don't find anything, then what we do, we'll return -1. I hope you get the flow of the question. Okay, let's move to the coding part and then we'll see how the approach could be. So I have coded it in C++. You guys can use any of the language. The things might be same. I have told you an approach. Okay, so the thing is, it's a C++ code. So first of all, what I have taken the int n is equals to a dot length. So in the first line, I have taken the n to be the length of the array, then L means left and R means right, M means the mid part. So binary search, mid is always required, and peak value is 0 right now. First of all, what I'll do, I'll find the peak. So for finding the peak, what I have to do is I have to travel from L equal to 0 to R equal to n minus 1. Okay, so placing 2 pointers, okay, from L left to be at 0 and right to be at the length of the array -1. Okay, not the length exactly, because that's the out of bound, because the array indexing starts from 0. Right now the while condition starts from L is less than R. Okay, so what should be the thing, like we have to find the mid. If our a dot get at mth position, at mid position, is less than a dot get m plus 1. Okay, so what's the case, like what this thing signifies? This thing signifies like we are moving from, for example, this is 1, this is 2. Okay, I'll move to the pencil. 1, then 2, then 3, then 4, then 5. Suppose we have moved to this point. Okay, in this point, is this m, okay, is this m is less than equal to this? Okay, this thing is greater or not? So no, so I'll move here. Okay, so 4 is like 4, this 5 is greater than 4, this will become the peak. In this way everything will be we'll search for everything. So like let me just do a dry run for you guys. Like for example, first of all, 1 1 will be there. Okay, so for example, the mid of this would be L plus R. So 1 2 3 4 5 6 7 elements are there. Okay, and 0 is the first. Okay, L is 0, and this one is 6. So 6 by 2, which is 3. So 3 is 0 1 2 3, which is 4 and 5 will be compared, and the condition will get satisfied. So peak will be m plus 1. Okay, so peak will be 5, and L is also 5. So accordingly this while loop will be executed, and after that while loop we'll get our peak. So, okay, so once we get our peak, then we have to target like the target in left array only. So the mountain that you are seeing, okay, so the mountain that you are seeing from 1 to 5, this thing to 5, so we have to search in this part only. So in searching in this part, simple binary search code, nothing very complicated. L0 R peak, L less than equal to R, find the mid. If it is less than the target, then left should be m plus 1, else the right should be m minus 1. So basic thing, and else return m. You can also do with like if it is equal to target, then return m, otherwise the else if conditions will be executed. So accordingly find in the right. So find in the right will start from peak to n minus 1, simple, and then again similar cases, no change to be honest. So a dot get is greater than if target, then what we'll do, if we'll basically L equal to m plus 1 in this case, and else if R is equals to m minus 1. Why? Because this is like decreasing array, so right one is decreasing and left one is increasing. That's why different conditions, but yeah, the things are literally the same. Afterwards return -1. So if I just run it and submit the code, so you guys can see that if I just run the code, so it will pass all test cases although I have submitted this code. Okay, so if I just see whether it is passing all the test cases or not, yeah, it is passing all the test cases. I hope you like the video, and if you do like the video, please give it the thumbs up, subscribe to my channel, and we'll bring more such content kind of videos to you guys. Thank you so much. My name is Rishabh Thakur, signing off. Hustle hard, and yeah, goodbye.